Hello again, this is Professor Matt Turner with Purdue Polytechnic, and you're watching a video lecture for ECET 364 covering electrostatics, which is the study of how stationary charges or slow-moving charges affect the space around them. And so this is in essence the study of static or unchanging electric fields. The objectives of today's lecture video are to use Coulomb's law to determine the force that's exerted on a charged particle by other charged particles, and then to also use Coulomb's law to evaluate the field strength in space due to these charged particles. And we're also going to use Coulomb's law to determine the E field at any distance away from an infinite line of charge. So in this situation, what we're going to look at is basically the effect of protons and electrons in the space that surrounds them. And in this example, what we're going to do is we're going to apply Coulomb's law to an infinite line of charge, which is a pretty good approximation of a current carrying wire. So if you can kind of think of having a wire, there's a lot of electrons flowing in it. Therefore, we've got an infinite line of charge, and we want to know, well, what's the electric field at any distance from that line of charge. This topic that we're going over today is about one half of what's called electromagnetostatics, which is electric and magnetic fields in static conditions. And the reason that we analyze this is that's what E&M waves are made up of, are electric and magnetic fields. And so we kind of break the study into two halves. One is the study of electric and magnetic fields that are stationary, and then we move on to electric and magnetic fields as they propagate through space, which we call plane waves. So this is kind of the first half of that, and we'll take a couple days to get through the static variant of electric and magnetic fields.